All right, let's pull back the curtain on something we all do probably 100 times a day. Just clicking a link. It feels like magic, right? Instant. But what's really happening behind the scenes is this incredible, high-speed journey across the entire globe. And that brings us to the big question.
I mean, really think about it. That tiny fraction of a second between your click and that web page loading, a whole series of complex events just fired off. And that's what we're going to do today. We're going to trace that journey step by step and really get to the bottom of how the web is built.
Okay, so the journey kicks off the second you click, right there in your web browser. The very first thing your browser has to do is put together a message. It needs to ask a server, could be anywhere in the world, for the website you want. But, it can't just ask in plain English. It's got to speak the right language.
And that language is called HTTP, or Hypertext Transfer Protocol. Your browser sends out what's called an HTTP request, and most of the time it's a super simple GET request. It's literally just saying, hey, server, get me the data for this web page. It's a clear, simple instruction that gets the ball rolling. But, okay, setting the request is the easy part. The real challenge is knowing where to send it. And right away, we hit our first major hurdle. See, your browser knows the name of the website you want, right? But the internet itself, the actual pipes and wires, it doesn't understand names. It only understands numbers. Every single thing on the internet, from your phone to the server hosting that website, has a unique number called an IP address. Think of it like this. You know your friend's name, but to mail them a letter, you need their actual street address. It's the exact same thing here. So the big question is, how do we get that address? How do we turn a name we can remember into a number the computers can use? Well, the answer is something called DNS, the Domain Name System. And honestly, the best way to think about DNS is as the internet's giant global address book. It's this massive shared database, and its entire job is to do that one translation, from name to number. And it does it in the blink of an eye. So, how does it work so fast? Well, it's this really clever chain of command. First, your computer asks a local DNS server, probably one from your internet provider. If that server doesn't know, no problem. It asks a root server way at the top. Now, the root server doesn't have the answer either, but it knows who's in charge of all the .com addresses, so it points you to the .com server, and that server knows exactly which final, authoritative server has the IP address you're looking for. It sounds like a lot of steps, but this whole thing happens in milliseconds. It's wild. Okay, great. So now our browser has the IP address. It knows exactly where to send that HTTP request. But, of course, we've got another problem to solve. We can't just fire off our request or get the website back in one huge chunk of data.
I mean, think about a modern web page. You've got text, tons of high-res images, all this complex code. Trying to send all of that in one go would be like trying to shove a whole car through a tiny mail slot. It just wouldn't work. It's clumsy, it's slow, and it would just jam up the whole network.
So the internet has a much, much smarter way of doing things. Instead of sending one giant file, it does the opposite. It breaks everything into these tiny little pieces. And these pieces are called packets. Everything you do online, I'm talking emails, streaming video, even that little HTTP request we just talked about, it all gets chopped up into hundreds or even thousands of these tiny packets. But wait, if everything's in tiny pieces, how on earth does the internet keep track of them all and put them back together? That is the job of a protocol called TCP, the Transmission Control Protocol. And the best analogy for TCP is that it's like the post office's certified mail service. It takes your big chunk of data, chops it up into packets, and slaps a number on each one. Then, on the other end, it makes sure all the numbered packets arrived and puts them back together in the right order. And get this, if a packet goes missing along the way, TCP notices and says, hey, send that one again. It's all about making sure nothing gets lost. So if TCP is the service that numbers and tracks the mail, what about the address? Well, that's where IP comes in, the Internet Protocol. Every single one of those little packets gets stamped with the destination IP address, the one we found using DNS. So you have TCP handling the packaging and assembly, and IP handling the addressing. Together, they get the data ready for its journey. All right, our packets are addressed, numbered, and ready to go. They're sent out from your computer, but they don't just travel down one single private road to the server. Oh no. They have to navigate the wild, sprawling maze that is the internet, which is really just a giant network of other networks. And this global maze is held together by millions of little devices called routers. A router's job is actually pretty simple, but it's absolutely crucial. You can think of a router as a traffic cop standing at a busy intersection. It looks at a packet, reads the IP address on it, and says, okay, you need to go that way to get one step closer to where you're going. And it does this for millions of packets a second.
So a single packet will make a bunch of hops on its trip. It leaves your home router, then hops to your internet provider's router. From there, it might jump across massive internet backbone routers that connect entire continents, hopping from one to the next until it finally lands at the router for the destination server. And here's the cool part. Each router makes its own decision about the best next hop, all working together to get your packet there as fast as possible.
Okay, so our data packets are bouncing all over the public internet, passing through all these routers owned by who knows how many different companies. And that should raise a pretty big red flag, right?
I mean, how can you be sure that someone isn't sitting in the middle, grabbing your packets and just reading everything inside? Your passwords, your credit card info, all of it. Because the internet itself isn't naturally private. We have to add a layer of security on top.
And that's where SSL and its more modern version, TLS, come into play. These protocols are basically the foundation of security online. What happens is, before any of your data gets sent, your browser and the server do this thing called a handshake. They basically agree on a secret code. And then they use that code to scramble or encrypt all the data inside your packets. So even if someone does grab them, all they see is a bunch of gibberish.
You actually see this all the time without even thinking about it. You know that little padlock icon you see in your browser's address bar? Or the S at the end of HTTPS? That's it. That's your signal that SSL or TLS is active and that your conversation with the server is private and secure. Your data is flying through an encrypted tunnel.
So after all that, after hopping across the globe and through that secure tunnel, our little packet with the HTTP request finally arrives at the server. And now, you guessed it, the whole thing happens all over again, but in reverse.
The server gets the request and goes, okay, I got it. It grabs everything it needs to build the web page, the HTML files, the style sheets, the interactive code, all the images, the whole shebang. It uses TCP to chop all that up into a brand new set of packets, stamps your IP address on them, and sends them flying right back to you through that same global maze of routers.
And that's it. That's the entire journey of a single click. Let's recap real quick. You click, which creates an HTTP request. DNS looks up the IP address. TCP and IP chop up and address the data into packets. Routers pass those packets across the internet. SSL/TLS make sure the whole conversation is secure. And finally, the packets arrive back at your browser. TCP puts them all back together and bam, the web page loads. All of that in less time than it takes to blink.
You know, what's really incredible is that this whole system, from DNS all the way to how routers talk to each other, it all works because of agreed upon rules and a basic level of trust. But as the internet gets more and more woven into our daily lives, that trust is being tested every single day with new security threats and all sorts of challenges. So the big question we have to ask is, how do we protect and evolve this incredible system to make sure it's open, reliable, and safe for all of us? It's definitely something worth thinking about the next time you make that simple little click.